One of the most fascinating things about software development is that you can basically choose an area where you are interested in and start working on it. For example, if you are interested in biology, you can get to a company that deals with biology and be a software developer there. If you are interested in economy, you can find a job as a software developer in a company that deals with economy and finance. If you're interested in construction, you can find a job as a software developer in a company that deals with construction. And if you want to get exposed to all these expertise, you can switch jobs. This is one of the most amazing things about being a software developer. However, if you are a lawyer, then most chances that you will be a lawyer in a specific field where you will be an expert, and basically that's it. If you studied biology, then most chances that you will deal with biology, maybe vaccinations. So this is very fascinating. Another fascinating aspect about software development is the connection to philosophy. For example, if we take how two computers communicate, we see that, let's say one computer is connecting to the stock exchange in New York and getting a value of a stock, transforms it into a JSON and passes it into computer B. So it needed to take the concept, the value of the stock, transform it into some kind of language, in this case some kind of keywords in JSON, transform it to the computer B, and computer B would be able to take it and decompose it, basically decode it and understand it. So when two human beings speak, when you meet your friend, you tell him, hey, what a nice hat you have. So person A looked at person B, got the image of the hat inside his brain, and now this image of the hat was inside his brain, and utilizing his amygdala, which is more of the sensations and feelings and emotions part of the brain, he was thinking that is a nice hat. And then he converted it into sound waves. In the process, he took this concept from his head, converted it into sounds. From the sounds, he was able to build words, and from the distinct words, he was able to build sentences. And then he took these sentences, converted to sound wave. This was like the processing. The input was the nice hat, the processing output sounds, and on top of the sounds words, and on top of the words combinations of words to have sentences, transform it into sound waves, transmit it into the other person. The other person would do all this decoding in reverse. And now the two people have this concept that only the first person, he was the only one in the world that had this concept of the nice hat, the niceness of the hat. And now this other person has been affected. His amygdala has been affected by the words that transmitted from the first person. This is pretty mind-blowing to think that two people can transfer the images and thoughts and even feelings by sound waves from one to another and by constructing. So the question is, how can we do this? How can human beings, what do they need in order to be able to do all this processing in seconds? I mean, it didn't take any time. He just saw the hat and told him, what a nice hat, and the other people just understood it. It didn't take any time, all this processing. Basically, the first person, and also the second one, needed to have a map from morphological words into meanings. So an average person has in between something like 60k to 300k of items in this map, which maps words into values, into meanings. This map, you don't need to have all the combinations. For example, if you say hat, then you don't need to have also as two keys in your brain, hat and hats. It's enough to have hat, and you'll be able to process it immediately. So this cache does not need to be that gigantic. You can store in the cache in your head only the basics of the words. And when you store this 60k to 300k, then you convert the items that you think and you compose a syntax out of it. And how do you do this composition of syntax? You do this with recursion. So you take nouns, verbs, and then you can recombine nouns, verbs, and recombine noun and verbs and construct. Hey, that's a nice hat that you have, a very nice hat. And with this recursion, you can create complex sentences. So the combinatorics, just think of it, all the words together with all the combinations it's an explosion of number of sentences that you can. Basically, you can, on the spot, I can say, hey, this earphone that I connected to my ear is very nice. And I didn't even need to connect it behind my ear. So I can promise you that I'm the only one in the world in the history of the evolution of the human race that said this sentence. No one else said it. And yet you managed to understand it in 1 second. This is because we have the basic understandings of the syntax. And you can do it very fast. You have this map for it, so you were able to take each word and map it to the value. And you also have the set of rules. So once I tell you all the set of words, then you have this set of rules. Now you can ask me whether, if I look at all the languages in the world, whether there could be an infinite number of rules in the languages. So the answer is no, because yes, almost all languages have a map of word to meaning, and they have the combinatorics of combinations of words into sentences, but there is no rule, there is no language with a rule that says that all sentences must begin with a noun. There is no such language. So yes, there is still a limit of the rules that can be applied and shared across all the languages. There is a big discussions in the linguistics in between whether language is a learned thing or language is just something that grows. And basically this discussion and in general the linguistic discussions has started from very early ages. I mean, Plato, Galileo, Darwin, Descartes and Chomsky in our age who's still alive are all debating in between themselves throughout the centuries whether people share language constructs in between themselves. For example, Darwin proved that the language is not a child instinct because, for example, there is no instinct for justice. Okay, the child is not born with the instinct for justice. And the word justice is still learned, meaning that we have constructed this word of justice. And so Darwin, in this way, has almost proved that language is not something instinctical to children. Another interesting thing about languages is that when you hear someone speaking in your native language, then you hear spaces. But the funny thing is that spaces do not exist of their own. Because if you listen to another language, then you would not hear these spaces. Or if someone who speaks a different language would listen to his language, he would not hear the spaces. The spaces are just something that we invent in our heads. Just like when you transmit a series of bits, there is no real separation of bytes. It's only the computer that takes these bytes and he understands with the protocol where is the separation of bytes. And if you look at the same bits, you would not be able, if you don't know what is the encoding, what is the separation of bytes. And let's conclude with the big idea of Noam Chomsky, who is maybe the greatest linguist of the 20th century and who is still one of the greatest linguists in the 21st century. His basic idea was basically that we do not learn language. It's something that grows. For example, your hair grows, hopefully. And so he said for language, it's not something that we learn. It's something that grows automatically. So it's built inside the brain. We have the building blocks. So as you know, when people talk to small children, they make funny noises. No, I'm not sure that Chomsky said something about it, but what I think is that these funny noises that people make to babies is that they emphasize the phonetics, they emphasize the sounds. And why? Because up to 12 months, the children are mostly interested, and they learn mainly the phonetics, the sounds, because up to 12 months they can learn any sound in the world. So I think this is why people make funny noises. It's like an evolutionary thing that people make funny noises to kids so that they would be trained on the sounds of the society they live in. And the basic thing that Chomsky said, that language is like growing like hair and it's not something that we learn. I don't think anyone can prove basically whether he's right or wrong. Maybe there were papers that said whether he's right or wrong, but I don't think it really is something, at least not in our time, to tell whether he's right or wrong. So this is the big idea of Chomsky. If you hear about Chomsky and you need to know what is his big idea, it's that language we are not learning. It's something that is built in and it's growing within us. So I think this was a very interesting summary of, in general, linguistics and languages. There is much to say about this. And I think also it was very interesting to see that software developers can transform from one fintech to biology to etc. versus other fields where you cannot really transform. If you're dealing with construction, then you're dealing with construction mainly. Okay, there are low aspects to this, but I think not biology. Too many aspects maybe there are. But as software developer, you can really delve into a subject, including language. And as we have seen, language is very tightly coupled to software development. So I think this was very interesting. Let me know what you think, and I'll see you next time.